Good evening. Tonight, we're diving into a story that begins not in the underground clubs of London or the warehouses of Detroit, but in the sterile, fluorescent-lit laboratories of mid-century America. A story of a molecule that was supposed to be perfect, safer, cleaner, better than what came before, a chemical savior born from the failures of its predecessor, designed to heal, to anesthetize, to protect. But like so many tales of human ambition meeting the messy reality of chemistry and consciousness, this one took a turn. A sharp, dissociative, reality-bending turn into places its creators never imagined and could never control. Before you settle in, take a moment to like this video and subscribe, but only if you genuinely find value in what we do here. Let me know in the comments where you're watching from and what time it is where you are. It's always fascinating to see this global community come together. Now, silence your notifications, take a deep breath, and let's begin. This is the story of ketamine, a drug that has been called many things: a battlefield miracle, a psychiatric breakthrough, a veterinary workhorse, a party drug, a treatment for depression, and a doorway to alternate dimensions. It is all of these things, and none of them completely. It is a mirror held up to society's relationship with altered consciousness, with pain, with healing, and with the desperate human need to escape the confines of ordinary reality. Our story doesn't begin with ketamine at all, but with its older, more dangerous sibling, a compound that would cast a long and terrifying shadow over American culture. In the laboratories of Parke Davis Pharmaceutical Company in Detroit, Michigan, in the year 1956, a young chemist named Victor Maddox was working on a problem that had plagued anesthesiology since its inception: how to render a patient completely unconscious for surgery without killing them in the process. The anesthetics of the mid-20th century were a mixed bag of barely controlled violence against the human nervous system. Ether was flammable and made patients vomit violently upon waking. Chloroform could stop the heart. The barbiturates could suppress breathing to the point of death. What the medical world desperately needed was something that could induce a state of complete unconsciousness, maintain it safely for hours, and then let the patient wake up cleanly, without the nightmare of respiratory depression or cardiovascular collapse. Maddox, working under the direction of Dr. Graham Chen, synthesized a compound with an ungainly chemical name: 1,1-phenylcyclohexyl piperidine. The shorthand was simpler: phencyclidine, or as it would come to be known in the streets and emergency rooms of America, PCP. The initial tests were promising, almost miraculous. When administered to test animals, PCP induced a state unlike anything the researchers had seen before. The animals didn't simply fall asleep, they entered a cataleptic trance, their eyes open but unseeing, their bodies rigid but their vital signs stable. Their pain reflexes disappeared entirely. You could perform surgery on them and they showed no response whatsoever. Yet their hearts kept beating, their lungs kept breathing, all without the constant, terrifying vigilance that other anesthetics required. Even more intriguing was what happened when the animals woke up. There was no grogginess, no prolonged stupor. They simply returned, as if they had been somewhere else entirely and had now stepped back into their bodies. This was exactly what Parke Davis had been searching for. They called it a dissociative anesthetic, a term that would become central to our story. The word dissociative was carefully chosen. It described the strange phenomenon the drug created: a separation, a fundamental disconnect between the mind and the body, between consciousness and physical sensation. The patient wasn't asleep in the traditional sense. They were elsewhere. Human trials began in 1957, and the results were both fascinating and deeply unsettling. Patients given PCP before surgery did indeed become insensible to pain. The drug worked exactly as advertised in that regard, but what they experienced internally was something the researchers had not anticipated and could not have prepared for. When the patients woke up, and this is where the nightmare began, many of them were not themselves. Some were agitated, violent, thrashing against restraints that hadn't been necessary moments before. Others were catatonic, staring at walls, unresponsive to their own names. Many reported terrifying hallucinations, spiders crawling from the walls, demons in the corners, the sensation of dying or having died. Some experienced what they could only describe as complete ego dissolution, the total and absolute loss of any sense of self, of being a person, of existing at all. They had been unmade and then poorly reassembled. The medical term for what these patients were experiencing was emergence delirium, a clinical phrase that utterly failed to capture the horror of the experience. These were not simple nightmares. These were profound, reality-shattering experiences that left some patients psychologically scarred, convinced they had glimpsed something beyond the veil of ordinary consciousness, something they were never meant to see. By 1965, after less than a decade of sporadic use, Parke-Davis quietly pulled PCP from the human market. It was too unpredictable, too dangerous, too likely to shatter a person's mind. But they didn't abandon it entirely. The drug was simply reassigned. It was reformulated for veterinary use under the trade name Cernal, marketed as an animal tranquilizer. For large animals, horses primarily, it was remarkably effective. A horse under PCP would stand perfectly still, eyes glazed, while a veterinarian worked. The animal felt no pain and showed no resistance. This should have been the end of PCP's interaction with humanity, a pharmaceutical failure relegated to the barns and stables. But PCP had already escaped. Like so many drugs before it, it had found its way to the street. In the late 1960s and early 1970s, as America's counterculture was exploring the outer limits of consciousness, with LSD, psilocybin and mescaline, PCP began appearing in underground drug markets. It was cheap to synthesize, requiring only basic lab equipment and readily available precursor chemicals. Street chemists could cook it up in converted garages and basements. It was sold under an ever-evolving roster of street names: angel dust, rocket fuel, embalming fluid, wet, sherm. The effects were nothing like the gentle consciousness expansion promised by the psychedelic prophets. PCP was violent, unpredictable, and profoundly dissociative in ways that defied description. Users reported feeling invincible, numb to all pain, disconnected from their bodies entirely. Emergency rooms began filling with PCP users who had mutilated themselves without realizing it, who fought police officers with superhuman strength, who believed they could fly and stepped off buildings. The drug created what psychiatrists called a pharmacologically induced psychosis, a temporary but complete break from reality that was indistinguishable from schizophrenia. And in some users, particularly those with underlying mental health vulnerabilities, this psychosis didn't end when the drug wore off. It lingered, sometimes permanently, a chemical lobotomy delivered in powder form. By the 1980s, PCP had become a cultural boogeyman, the subject of sensational news reports and anti-drug propaganda. It was the drug that made people crazy, the drug that turned users into monsters. Nancy Reagan's Just Say No campaign featured PCP prominently. It was everything parents feared about the drug culture distilled into one terrifying substance. But here's the thing about PCP that the moral panic obscured. Buried beneath the horror stories and the emergency room nightmares was a real, genuine pharmacological innovation. The concept of dissociative anesthesia was sound. The ability to separate consciousness from sensation, to create a state where surgery could be performed without traditional anesthetics, where pain could be abolished without the deadly risk of respiratory depression. This was genuinely revolutionary. The problem wasn't the concept. The problem was the execution. PCP was too powerful, too unpredictable, too prone to inducing madness. What the medical world needed was a gentler version, a dissociative anesthetic that could deliver the promise without the nightmare. In a laboratory at Parke-Davis, a chemist named Calvin Stevens was already working on exactly that. Calvin Stevens was not trying to create a party drug or a psychiatric medication or a tool for exploring consciousness. He was trying to solve a problem, the same problem that had created PCP, the need for a safer anesthetic. Working systematically through variants of the phencyclidine molecule, Stevens was looking for something with similar anesthetic properties, but without the terrifying emergence reactions. In 1962, he synthesized compound CI-5-odeswan, the 581st compound in the series. Its chemical name was even more unwieldy than PCP's: 2,2-chlorophenyl, 2-methylamino cyclohexanone. But the structure was elegant, a modification of PCP with subtle but crucial differences. The initial animal tests were encouraging. CI-581 produced the same cataleptic state, the same profound anesthesia, the same remarkable cardiovascular stability. But the recovery was different, cleaner. The animals woke up without the violent agitation that had plagued PCP. The compound needed a name. Stevens and his colleagues settled on ketamine, derived from its chemical structure, a ketone and an amine group. It was clinical, forgettable, perfect for a pharmaceutical product. But before ketamine could be tested in humans, Parke-Davis needed someone willing to be the first. They needed a physician who understood anesthesia, who understood risk, and who had the courage, or perhaps the recklessness, to inject himself with a completely unknown substance derived from one of the most notorious drugs in recent medical history. They found their man in Dr. Edward Domino, a pharmacologist at the University of Michigan, with a particular interest in anesthetics and psychoactive drugs. Domino had worked with PCP. He knew its promise and its peril. When Parke-Davis approached him about testing this new compound, he agreed, but with one condition: he would be the first human subject. On August 3, 1964, in a carefully controlled laboratory setting, with medical equipment standing by and colleagues monitoring every vital sign, Edward Domino injected himself with 100 milligrams of ketamine. What happened next would change the course of anesthesiology, psychiatry, and eventually nightclub culture around the world. Domino later described the experience with the careful precision of a scientist trying to articulate something that resisted scientific language. He felt a profound sense of dissociation, a feeling of floating away from his body. But unlike PCP, it wasn't terrifying. It was peaceful, strange, certainly, deeply unusual, but not frightening. He experienced what he called a dreamlike state, vivid mental imagery that seemed more real than the laboratory around him, a sense of being in multiple places simultaneously. His body felt distant, almost irrelevant, as if it were a vehicle he had temporarily parked while his consciousness went elsewhere. But throughout it all, he maintained a core awareness of who he was. His ego didn't dissolve completely, as it had for so many PCP users. It simply relocated. When Domino returned to baseline consciousness about an hour later, he felt clear-headed, refreshed almost. There was no emergence delirium, no violent thrashing, no psychotic break. Just a gradual reintegration, a slow return to ordinary reality. This was it. This was the dissociative anesthetic they had been searching for. The next phase of testing moved to volunteer prisoners at Jackson Prison in Michigan, a common practice in pharmaceutical research at the time that would be considered deeply unethical today. The results were consistent with Domino's experience. The prisoners reported strange dreamlike states, out-of-body experiences, a sense of profound detachment. But the experiences were manageable and the recovery was clean. In 1966, Parke-Davis released ketamine for human use under the trade name Catala. It was approved specifically for use as a general anesthetic, particularly for short surgical procedures and for use in patients where traditional anesthetics were too risky. The medical community's reception was cautious but interested. Ketamine had several remarkable properties that made it uniquely valuable. First, cardiovascular stability. Unlike most anesthetics, which could cause dangerous drops in blood pressure, ketamine actually tended to maintain or even slightly elevate blood pressure and heart rate. This made it ideal for trauma situations, for patients in shock, for battlefield medicine. Second, respiratory stability. Ketamine did not suppress breathing the way opioids and barbiturates did. Patients under ketamine continued to breathe on their own, maintaining their protective airway reflexes. They could even keep breathing if they vomited, dramatically reducing the risk of aspiration. Third, rapid onset and offset. Ketamine worked fast. Unconsciousness within seconds when given intravenously, within minutes when injected into muscle. And it wore off relatively quickly, with patients typically regaining consciousness within 15-30 minutes, though the full cognitive effects could linger for hours. But ketamine had one property that both fascinated and troubled physicians: the dissociative experience itself. Patients emerging from ketamine anesthesia often reported having had vivid, complex experiences during their surgery. They described floating above their bodies, traveling through space, encountering entities or presences, experiencing profound revelations about the nature of reality. Some found it spiritual, transcendent, the most meaningful experience of their lives. Others found it disturbing, unsettling, a violation of their sense of self. The medical literature began referring to this as the emergence phenomenon, a deliberately neutral term for something that was anything but neutral. Studies found that approximately 10–30% of patients experienced these unusual psychological reactions, with the percentage varying based on dose, route of administration, and individual psychological factors. Anesthesiologists developed strategies to manage this. They would administer ketamine in combination with benzodiazepines like Valium, which seemed to dampen the psychedelic effects without eliminating the anesthetic properties. They would keep recovery rooms quiet and dimly lit, minimizing external stimulation that might be incorporated into the dissociative experience. They would carefully screen patients, avoiding ketamine in those with psychiatric histories who might be more vulnerable to disturbing experiences. But these strategies could only go so far, because the truth was the dissociative experience wasn't a side effect of ketamine, it was ketamine. The separation of consciousness from sensation, the sense of being somewhere else. This was the fundamental mechanism of action. You couldn't have the perfect anesthetic properties without also having the consciousness-altering effects. They were two sides of the same pharmacological coin. Still, for the right patients and the right circumstances, ketamine was miraculous, and one of those circumstances was about to arrive in the form of America's most controversial war. In 1970, as American involvement in Vietnam reached its bloody peak, military physicians faced an impossible challenge. They were dealing with casualties on a scale and of a severity that modern warfare had made possible, but that medical science was barely equipped to handle. Young men were being torn apart by bullets, shrapnel, and high explosives in the dense jungles and rice paddies of Southeast Asia, often miles from any proper medical facility. The standard protocol for battlefield anesthesia was morphine, the same opiate that had been used since the Civil War. But morphine had a fatal flaw. It suppressed breathing. In a soldier who was already in shock, already struggling to maintain blood pressure and oxygen levels, morphine could be the final insult that pushed them over the edge. Too many soldiers were dying not from their injuries directly, but from the very drugs meant to ease their pain and prepare them for surgery. The military needed something different. They needed an anesthetic that wouldn't kill the patient, that worked fast, that could be administered in the field by medics with minimal training, that didn't require complex monitoring equipment or constant adjustment. They needed ketamine. Military physicians had been watching ketamine's development with interest since its approval in 1966. The drug's unique properties, its cardiovascular and respiratory stability, its rapid onset, its ability to be administered intramuscularly when intravenous access was impossible, made it almost perfectly suited for combat medicine. In 1971, Ketamine was added to the field medical kits of combat medics serving in Vietnam. The impact was immediate and profound. A medic could inject ketamine directly into a wounded soldier's thigh muscle, right there in the field, while bullets were still flying overhead. Within minutes the soldier would be unconscious, insensible to pain, stable enough to be moved. The medic didn't need to manage an airway or worry about the soldier stopping breathing. They could focus on stopping the bleeding, on getting the casualty to a field hospital, on saving the life in front of them. In the mobile army surgical hospitals, the MASH units that would later be romanticized in television, but were in reality blood-soaked tents of controlled chaos, ketamine revolutionized trauma surgery. Surgeons could anesthetize multiple casualties rapidly, working assembly line style through the horrific parade of injuries that modern warfare produced. They could maintain anesthesia for hours if needed, simply by giving additional doses, and crucially they could do it all without the constant terror that their anesthetic would kill the patient before the injuries did. Estimates vary, but it's believed that ketamine was used in approximately 90% of anesthetic procedures in Vietnam by the war's end. It saved thousands of lives, perhaps tens of thousands. For many surgeons and medics who served in Vietnam, ketamine wasn't just another drug in the formulary. It was a miracle, the chemical that made their impossible job merely difficult. But this widespread use created something else as well. A generation of American soldiers who had experienced ketamine's dissociative effects firsthand, and some of them, traumatized by war, haunted by what they had seen and done, found something valuable in that dissociation. A way to separate themselves from their trauma, to float above their PTSD, to find a few hours of peace in the place ketamine took them. When these veterans came home, some of them brought their knowledge of ketamine with them, and the drug began its slow leak from the medical world into the recreational underground. But that transformation was still years away, because in the 1970s and early 1980s, ketamine was having another moment, this time not on battlefields or in operating rooms, but in psychiatry offices and research laboratories, where scientists were trying to understand not just how to use ketamine, but what it might reveal about the fundamental nature of consciousness itself. In the 1970s, a small group of psychiatrists and psychologists were asking a question that the medical establishment found uncomfortable, perhaps even dangerous. What if the dissociative experience produced by ketamine wasn't a side effect to be managed, but a therapeutic tool to be harnessed? This was not a new idea. The previous decade had seen an explosion of research into psychedelic therapy, primarily using LSD and psilocybin. Researchers at institutions like Johns Hopkins, Harvard, and UCLA had conducted hundreds of studies suggesting that psychedelic experiences, carefully guided in therapeutic settings, could help treat alcoholism, depression, anxiety in terminal patients, and various other psychiatric conditions. But by 1970, the political winds had shifted. LSD had escaped the laboratory and become the sacrament of the counterculture. Timothy Leary was telling young people to turn on, tune in, drop out. The establishment panicked. Richard Nixon declared drugs public enemy number one. In 1970, the Controlled Substances Act classified LSD, psilocybin, and other psychedelics as Schedule E substances, defined as having no medical value and high potential for abuse. Research ground to a halt. Labs were shut down. The psychedelic therapy movement was buried under an avalanche of criminalization and moral panic. But ketamine slipped through a crack in the wall. It was legal, approved, already in use in hospitals across America. It couldn't be easily banned without disrupting medical practice, and so a few researchers, carefully, quietly, continued the work that had been forced underground for other psychedelics. One of the pioneers was Dr. John Lilly, a neuroscientist and psychoanalyst who had already made his name studying dolphin communication and consciousness. Lilly was fascinated by ketamine from his first experience with it in 1972, but he wasn't interested in using it as an anesthetic. He wanted to use it as a tool for exploring consciousness, for mapping what he called inner space. Lilly's approach was radical. He would take high doses of ketamine, far beyond what would be used medically, and then float in a sensory deprivation tank, cutting off all external input. In this void, with his consciousness unmoored from both his body and the outside world, Lilly reported travelling to what he described as alternate realities, encountering non-human intelligences, experiencing states of consciousness that seemed to exist independent of the brain. His writings on these experiences, collected in books like The Scientist and The Center of the Cyclone, were a strange blend of rigorous neuroscience and mystical speculation. They influenced a generation of consciousness researchers, therapists, and eventually recreational users who saw in ketamine not just a drug, but a portal. More conventionally, some psychiatrists began using low doses of ketamine in psychotherapy sessions. The idea was that ketamine's dissociative effects could help patients achieve emotional distance from traumatic memories, allowing them to process and integrate experiences that were otherwise too painful to confront directly. Dr. Evgeny Krupitsky in Russia conducted extensive studies using ketamine-assisted psychotherapy for alcohol addiction. His research, published throughout the 1990s and 2000s, suggested that a single high-dose ketamine session combined with psychotherapy could help alcoholics maintain sobriety far longer than traditional treatments. He theorized that the profound, often mystical experiences induced by ketamine created what he called a transformation of the personal self, a fundamental shift in identity and values that made continued drinking psychologically incompatible. In the United States and Europe, small pockets of therapists experimented with using ketamine for PTSD, depression, and end-of-life anxiety in terminal patients. The results were often remarkable. Patients who had been trapped in cycles of depression or anxiety for years reported sudden dramatic improvements after ketamine sessions. They described the experiences as revelatory, as providing perspective on their problems that years of talk therapy had failed to achieve. But this research remained marginal, underfunded, and viewed with suspicion by mainstream psychiatry. The spectre of the 1960s psychedelic movement loomed large. Any suggestion that consciousness-altering drugs might have therapeutic value was tainted by association with hippies and Haight-Ashbury and the cultural chaos of that era. What these early ketamine researchers didn't fully understand yet, what the science of the time wasn't sophisticated enough to reveal, was that ketamine was doing something fundamentally different in the brain than psychedelics like LSD or psilocybin. It wasn't primarily working through the serotonin system, the traditional target of psychedelic drugs. It was working through the glutamate system, specifically by blocking NMDA receptors, a mechanism that had profound implications not just for consciousness, but for the very structure and function of neurons. This mechanism would eventually lead to ketamine's rebirth as a psychiatric medication. But that discovery was still decades away. In the 1970s and 1980s, ketamine remained primarily an anesthetic, with a small devoted following of therapists and consciousness explorers convinced of its potential. And then there was the veterinary practice. While psychiatrists were exploring ketamine's effects on human consciousness, and surgeons were using it to anesthetize patients, veterinarians had discovered that ketamine was absolutely perfect for their needs. Animals, unlike humans, can't be reasoned with. You can't explain to a dog that the surgery will help, that the pain is temporary, that they need to hold still. Large animals, horses particularly, are powerful and dangerous when frightened or in pain. Traditional veterinary anesthesia was a nightmare of risk and complexity. Ketamine changed everything. A quick injection, and a horse would enter that characteristic cataleptic state, standing perfectly still with glazed eyes, completely unaware of the scalpel opening its flesh. The animal's vital signs remained stable. There was no need for intubation, no need for complex monitoring. The veterinarian could work in peace, and the animal would recover cleanly once the drug wore off. For smaller animals, cats, dogs, exotic pets, ketamine became the go-to anesthetic for minor procedures. It was so standard, so ubiquitous in veterinary practice, that it was simply called the vet drug in many clinics. But this ubiquity created a problem. Veterinary clinics across the country had bottles of ketamine sitting in their drug cabinets. In the 1980s, many of these clinics had relatively lax security. Ketamine was not a controlled substance, in the same way as morphine or barbiturates. It was legal, medical, considered low risk. This made veterinary clinics the perfect target for theft. And as word spread in certain underground communities about ketamine's consciousness-altering properties, these thefts began to occur with increasing frequency. A veterinary technician with access to the drug cabinet could pocket a vial here and there. A veterinary student could siphon off doses during clinicals. A burglar could smash a window at night and be in and out in minutes, leaving with a fortune in pharmaceutical-grade ketamine. The liquid from these vials, pharmaceutical-grade ketamine hydrochloride, was typically 100 ml, clear and colourless, indistinguishable from water. It could be injected directly, or more commonly, it could be evaporated to create a white crystalline powder that could be snorted, far more practical for recreational use than carrying around vials of liquid. The process was simple. Pour the liquid into a glass baking dish. Let it sit in a warm, dry place or use low heat. Wait for the water to evaporate. Scrape up the crystals. Package them. Sell them. By the late 1980s, there was a steady trickle of veterinary ketamine moving from clinics into the underground drug market. But it was still relatively obscure, known primarily to a niche group of psychonauts and consciousness explorers, people who were deliberately seeking out unusual psychoactive experiences. That was about to change, because ketamine was about to collide with a musical and cultural movement that would propel it from the margins to the mainstream, from the consciousness researchers' laboratories and veterinary clinics to the dance floors of London, Ibiza, and eventually the world. To understand how ketamine became a party drug, you have to understand the party, and in the late 1980s and early 1990s, a new kind of party was being born in the warehouses and fields of England. It wasn't just a party, it was a movement, a mass experience of collective euphoria enabled by a three-part trinity: MDMA, ecstasy, electronic dance music, and spaces large enough to hold thousands of bodies moving as one organism to a relentless 4/4 beat. Rave culture exploded across the UK in 1988 and 1989. What participants called the Second Summer of Love. Thousands of young people would gather in secret locations, abandoned warehouses, aircraft hangars, open fields, announced only by word of mouth and cryptic flyers. They would dance from midnight until dawn, fueled by ecstasy and the transcendent, almost religious experience of losing themselves in the music and the crowd. MDMA was perfect for this. It broke down social barriers, creating feelings of profound empathy and connection. It gave energy without the jittery paranoia of amphetamines. It made the music feel like it was rewiring your soul. Raves on MDMA were not just fun, they were transformative, spiritual, a secular church for a generation that had rejected traditional religion. But MDMA had limitations. The more you used it, the less effective it became, as the brain's serotonin system depleted and took longer to recover. Regular ravers, those going out multiple nights a week, found their magic pills weren't so magical anymore. And the come down from MDMA, the depression, the emotional flatness, became harder to manage with repeated use. The scene needed something else, something different, something that could be rotated with MDMA, that could provide a different kind of experience, that could keep the party going. Enter ketamine. It's unclear exactly when and where ketamine first entered the rave scene. The drug had been present in underground party culture in America since at least the early 1980s, particularly in San Francisco and Los Angeles, where it was used in smaller doses at clubs and after-parties. But it was in the UK rave scene of the early 1990s that ketamine found its true home and its identity as a club drug. Ketamine was different from MDMA in almost every way. Where MDMA made you empathetic and connected, ketamine made you detached and introspective. Where MDMA made you want to talk and hug, ketamine made communication difficult and physical touch feel distant. Where MDMA enhanced the music, ketamine seemed to deconstruct it, turning it into geometric patterns of pure sound. But this difference was exactly what some ravers were looking for. After hours of MDMA-fueled dancing and socializing, as the sun was coming up and the party was winding down, ketamine offered a different journey. A chance to sit or lie down in a quiet corner, a chill-out room in rave parlance, and go inward to process the night's experiences, to explore the strange spaces of consciousness that ketamine opened up. The doses used in the rave scene were typically much lower than those used medically for anesthesia. A bump of ketamine, a small amount snorted from a key or a specialized small spoon, might be 30-50 milligram, enough to produce mild dissociative effects, a feeling of floating, a pleasant confusion, without the complete separation from reality that higher doses produced. But some users went deeper. They would take enough ketamine to enter what the scene began to call the K-hole, a state of near-complete dissociation where the user became immobile, unresponsive to the external world, lost in an internal landscape that could be anything from transcendent to terrifying. The K-hole experience defied easy description, but ravers tried. They talked about tunnels of light, about geometric spaces that existed independent of normal 3D reality, about encountering entities or presences, about experiencing themselves as pure consciousness without a body. Some described it as like being dissolved and reassembled. Others said it felt like dying. Many said it was the most profound experience of their lives. The K-hole became a rite of passage in certain sectors of rave culture, something to be attempted at least once, though not something most people wanted to repeat regularly. It was too intense, too unpredictable, too far from the social, collective experience that brought most people to raves in the first place. Ketamine use in the rave scene established several patterns that would persist as the drug spread. First, it was primarily used nasally. Snorting ketamine was far more practical in a party environment than injecting it. The onset was slower than IV use, about 10 minutes versus seconds, which made the experience more manageable and less likely to overwhelm the user. Second, it was often used in combination with other drugs. Ravers would mix ketamine with MDMA, a combination called kitty flipping, with cocaine, for energy, with cannabis, to smooth the edges. These combinations could be synergistic or dangerous, depending on doses and individual chemistry. Third, it developed a reputation as a drug that could be problematic. Stories circulated of people lost in the K-hole, of users who couldn't walk or communicate, who needed to be watched over by friends for hours. There were occasional reports of injuries, people falling down, wandering into dangerous situations while dissociated, having accidents. But ketamine also had a social aspect that made it particularly suited to certain party contexts. It was a drug you could share with strangers in a dark room, passing around a bag or a vial, bonding through the shared weirdness of the experience. There was an ethos of care around it. If someone went too deep into the K-hole, others would watch over them, create a safe space for them to ride it out. By the mid-1990s, ketamine had become a staple of the UK club scene. It was particularly associated with certain types of electronic music, ambient, downtempo, psychedelic trance, genres that emphasized texture and atmosphere over the hard, driving beats of mainstream techno or house. Clubs began to accommodate ketamine users by creating dedicated chill-out spaces, quiet rooms with cushions and dim lighting where people could go on a journey. The drug spread through Europe's festival circuit, Glastonbury, Boom Festival in Portugal, the massive trance festivals in Goa, India. Each scene adapted ketamine to its own culture and context, but the core experience remained the same, a legal-ish, easily available substance that could take you very far from ordinary consciousness, if that was what you were seeking. While ketamine was becoming a fixture of European club culture, it was having a parallel evolution in the United States, though with some distinctly American characteristics. In the early 1990s, Los Angeles and San Francisco had thriving underground party scenes. influenced by the UK rave movement but with their own flavour. The Mojave Desert, particularly the area around Zizix, pronounced Zizix, became legendary for massive outdoor desert parties where thousands would gather, often on federal land, technically illegal, but largely ignored by authorities stretched too thin to care. Ketamine found a home in these desert gatherings. The vast open spaces, the stars overhead, the alien landscape of the Mojave, all of this seemed to enhance ketamine's reality-bending properties. Users would wander out into the desert on ketamine, experiencing the landscape as something alien and otherworldly, the rocks and sand seeming to breathe and shift. But ketamine's spread in America was accelerated by a distinctly American phenomenon, the jam band scene. Bands like the Grateful Dead had long fostered a travelling community of fans who would follow the band from show to show, creating a mobile culture complete with its own economy, social structures, and drug preferences. When Jerry Garcia died in 1995, effectively ending the Grateful Dead as a touring entity, this community needed new bands to follow. They found them in groups like Fish, String Cheese Incident, and the Disco Biscuits, bands that played long improvisational shows, often incorporating electronic elements, creating soundscapes that were perfect for psychedelic experiences. The jam band scene was traditionally associated with LSD and mushrooms, the classic psychedelics of the hippie era. But ketamine began to appear at these shows, particularly at late-night after-parties. The jam band community brought something different to ketamine use. They intellectualized it. This was a scene that valued consciousness exploration, that read books about psychedelics, that discussed set and setting, that approached drug use as a form of personal and spiritual development rather than mere intoxication. Users in this scene began to talk about ketamine as a tool for exploring non-ordinary states of consciousness, for accessing what some called the cosmic consciousness, or the universal mind. The K-hole was framed not as passing out or getting too fucked up, but as a legitimate mystical experience, something akin to what medieval mystics or Eastern meditators reported. This philosophical framing helped ketamine gain acceptance in certain countercultural communities that might have been skeptical of a drug known primarily as a horse tranquilizer. It wasn't just a party drug, it was a teacher, a tool, a sacrament. But this spread also brought ketamine to the attention of law enforcement and regulators. The drug's legal status was in a grey area. It wasn't scheduled under the Controlled Substances Act, but it also wasn't completely unregulated. It was a prescription medication, meaning possession without a prescription was technically illegal, but it wasn't a priority for enforcement. That began to change in the late 1990s as ketamine use became more visible and more widespread. Emergency rooms were seeing more cases of acute ketamine intoxication. Police were finding it at raves and concerts. And then came the reports that really got the attention of lawmakers and the media. Ketamine was being used as a date rape drug. In the mid to late 1990s, a series of assault cases began to emerge where ketamine was implicated as an incapacitating agent. The drug's dissociative properties, which made users detached and unable to move or effectively resist, made it a tool for sexual predators. Ketamine could be added to drinks. It was colourless and nearly tasteless in small amounts. A victim dosed with ketamine would become confused, unable to form coherent thoughts or coordinate their movements, often with amnesia for the period of intoxication. They would appear extremely drunk or drugged, but in a way that was hard to distinguish from someone who had simply overconsumed alcohol. These cases, when they came to light, were horrifying. Victims described nightmarish experiences of being aware but unable to move or speak, of their assaults occurring in a dreamlike dissociated state that made the memories fragmented and difficult to process or report. Media coverage of these cases was sensationalistic and widespread. Ketamine was lumped together with GHB and Rohypnol as part of a triumvirate of date rape drugs. News programs ran special segments teaching women how to watch their drinks, to never leave a glass unattended, to use drink covers and test strips. The reality was more complicated than the media narrative suggested. Studies attempting to determine how often ketamine was actually used in sexual assaults found that it was relatively rare compared to alcohol, which was by far the most common substance involved in drug-facilitated sexual assault. When ketamine was involved, it was often because the victim had taken it voluntarily in a party context, and then someone had taken advantage of their incapacitated state rather than the drug being administered secretly. But the damage to ketamine's reputation was done. The drug was no longer just a consciousness-exploring tool or a party drug. It was associated with predation, with violation, with the worst kind of criminal behavior. This association accelerated calls for regulation. In 1999, ketamine was designated as a Schedule III controlled substance in the United States, placing it in the same category as anabolic steroids, certain barbiturates, and less abusable opioids. Possession without a prescription became a federal crime punishable by up to 5 years in prison. Manufacturing or distributing ketamine could result in up to 10 years. Other countries followed suit. The UK, Canada, Australia all moved ketamine from unscheduled to controlled status. The era of easy access was ending, but scheduling ketamine created a paradox. Making it a controlled substance didn't significantly reduce its availability in the party scene, it just shifted the supply chain. Instead of veterinary clinic thefts, ketamine began to be manufactured in clandestine laboratories, particularly in China and India, where it could be produced cheaply and shipped internationally. The quality became more variable. Users couldn't be as sure of what they were getting or how pure it was. Meanwhile, legitimate medical and research use became more complicated. Doctors had to navigate additional paperwork and scrutiny to prescribe or study ketamine. Research into its therapeutic potential was hampered by the regulatory burden. As the millennium turned and the 2000s began, ketamine seemed to be entering a dark period. It was losing its counterculture cachet, associated now with dangerous extremes of use, with predatory behavior, with regulatory crackdown. The party scene was moving on to other substances. MDMA was still king, and new drugs like mephedrone and other research chemicals were appearing. For a few years, it seemed like ketamine might fade into obscurity, remembered as a strange interlude in drug culture, a veterinary anesthetic that had a brief, weird run as a club drug before being relegated to the margins. But ketamine had one more transformation ahead of it, and this one would be the most surprising of all. A resurrection not in the clubs or the desert raves, but in the pristine, evidence-based world of academic psychiatry. The horse tranquilizer was about to become, against all odds, one of the most important psychiatric medications of the 21st century. In the early 2000s, psychiatric medicine was in a state of frustration. Depression, which afflicted hundreds of millions of people worldwide, was treated primarily with a class of drugs called selective serotonin reuptake inhibitors, SSRIs like Prozac, Zoloft, and Paxil. These drugs worked for many people, but they had significant limitations. They took weeks to start working, leaving acutely suicidal patients in danger during the lag period. They only worked for about 2/3 of people who tried them, and for treatment-resistant depression, patients who had tried multiple antidepressants without relief, the options were extremely limited, often requiring intensive interventions like electroconvulsive therapy. The pharmaceutical industry had been throwing billions of dollars at the problem for decades, developing dozens of variations on the SSRI theme. But they were all fundamentally working through the same mechanism, increasing serotonin levels in the brain. The returns were diminishing. At the National Institute of Mental Health, a researcher named Dr. Carlos Zarate was looking in a different direction. He was interested in the glutamate system, the brain's primary excitatory neurotransmitter system, which had been relatively unexplored as a target for antidepressants. And he was particularly interested in drugs that blocked NMDA receptors, a specific type of glutamate receptor. One such drug was ketamine. Ketamine's antidepressant potential wasn't a completely new idea. There had been small studies and case reports going back to the 1970s, suggesting that ketamine could rapidly improve mood in depressed patients. But these reports had been dismissed or ignored by mainstream psychiatry. Ketamine was an anesthetic, a club drug, a substance of abuse. It wasn't taken seriously as a psychiatric medication, but Zarate was willing to look past the stigma. In 2000, his team at NIMH began a carefully designed study. They recruited 17 patients with treatment-resistant depression, people who had tried multiple antidepressants without relief, people who had been depressed for years. They gave them a single dose of ketamine, administered intravenously over 40 minutes, at a dose far below what would be used for anesthesia. The results, published in 2006 in the Archives of General Psychiatry, were stunning. Within hours, not weeks, hours, 71% of the patients showed a significant reduction in their depression symptoms. Some patients who had been suicidal, who had been unable to get out of bed, reported feeling normal for the first time in years. The effect didn't last. Most patients relapsed within a week or two, but that almost didn't matter. The fact that it worked at all, that a single dose of a drug could lift severe treatment-resistant depression in a matter of hours, was revolutionary. It challenged fundamental assumptions about what depression was and how it could be treated. The finding was replicated in subsequent studies. Again and again, researchers found that ketamine produced rapid, robust antidepressant effects in patients who had not responded to conventional treatments. The effect size, the measure of how much the drug helped, was larger than that of any standard antidepressant. More studies revealed another remarkable property. Ketamine seemed to rapidly reduce suicidal ideation, even in patients who remained somewhat depressed. This was unprecedented. The ability to quickly diffuse a suicidal crisis could be genuinely life-saving. The psychiatric community was electrified. Here was a potential paradigm shift, a new mechanism of action that could help patients who had been failed by everything else. But there were significant problems to overcome. First, the duration problem. The antidepressant effect of a single ketamine dose typically lasted only a week or two at most. This meant patients would need repeated treatments to maintain the benefit. How often? How many times could ketamine be administered safely? Second, the abuse potential. Ketamine was a drug of abuse. Could it be prescribed for depression without creating a new population of addicts? How would psychiatrists prevent diversion and misuse? Third, the dissociative experience. The psychoactive effects of ketamine, the sense of detachment, the unusual perceptions, were they essential to the antidepressant effect, or were they separable? Could a version of ketamine be developed that treated depression without also altering consciousness? Fourth, the route of administration. The successful studies had used intravenous infusion, which required patients to come to a clinic for 40-minute sessions. This was impractical for widespread use. Could ketamine be given in other ways? Researchers and pharmaceutical companies began working on these problems. Studies of repeated ketamine, infusions, typically twice a week for several weeks, showed that the antidepressant effect could be maintained with ongoing treatment, though there were concerns about tolerance and long-term safety. Intranasal formulations were developed, allowing ketamine to be administered as a nasal spray rather than an IV infusion. In 2019, the FDA-approved esketamine, Spravato, a nasal spray formulation of ketamine's S-enantiomer, specifically for treatment-resistant depression. It was the first truly new mechanism of action for an antidepressant approved in decades. The approval came with significant restrictions. Esketamine could only be administered in certified clinics under medical supervision. Patients had to be monitored for at least 2 hours after each dose. It was classified as a controlled substance. The cost was astronomical, often thousands of dollars per month. But despite these limitations, ketamine had achieved something remarkable. Full rehabilitation from discredited club drug to FDA-approved psychiatric medication. The transformation was complete. The FDA's approval of esketamine and the growing body of research on ketamine's antidepressant effects created a new medical phenomenon, the ketamine clinic. These clinics began appearing across the United States and other countries, offering intravenous ketamine infusions for depression, anxiety, PTSD, and various other psychiatric conditions. They operated in a legal grey area, using ketamine off-label for indications beyond its FDA-approved anesthetic use, but the practice was permitted under medical discretion. The typical ketamine clinic experience went something like this. A patient, usually someone who had tried multiple antidepressants without success, would be screened by a psychiatrist to ensure they were appropriate for ketamine treatment. If approved, they would come to the clinic for their first infusion. The setting was designed to be calming, dim lighting, comfortable recliners, often headphones with carefully selected music. The patient would receive an IV line, and ketamine would be infused slowly over 40 minutes to an hour. The dose was calibrated to produce a mild to moderate dissociative experience without full anesthesia. During the infusion, many patients reported having profound, sometimes mystical experiences. They described feeling their depression as something separate from themselves, seeing their problems from a new perspective, experiencing a sense of connection to something larger. Whether these experiences were essential to the therapeutic effect or merely a byproduct remained hotly debated. After the infusion, patients would rest in the clinic for an hour or two as the effects wore off, then be released to go home. They couldn't drive themselves. They needed someone to pick them up. The typical protocol was 6 infusions over 2-3 weeks, followed by maintenance infusions every few weeks or months as needed to sustain the effect. The results varied widely. Some patients experienced dramatic, life-changing improvements. People who had been depressed for years, who had been unable to work or maintain relationships, reported feeling like themselves again for the first time in memory. The effect could be fast enough to be shocking, a patient entering the clinic suicidal and leaving a few hours later with hope. But not everyone responded. Studies suggested that about 50–70% of treatment-resistant depression patients got meaningful benefit from ketamine, which was better than most alternatives but still left a significant minority without relief. And there were concerns. The long-term effects of repeated ketamine use were not well understood. The drug was known to cause bladder problems with chronic use, ketamine bladder, a painful condition of bladder inflammation that had been observed in heavy recreational users in Asia. Could these problems develop in medical patients receiving regular infusions? There were also questions about the sustainability of the model. Ketamine clinics were expensive, often not covered by insurance. The treatment could cost thousands or even tens of thousands of dollars. This created a two-tier system where the wealthy could access this potentially life-saving treatment, while others could not. Some critics argued that the ketamine clinic boom was partially driven by profit motive, that clinics were overselling an experimental treatment, that they were capitalizing on desperate patients. They pointed to clinics that claimed to treat conditions beyond depression, that offered ketamine for chronic pain, for addiction, for conditions where the evidence base was thin or non-existent. Regulators struggled to keep up. How should ketamine clinics be overseen? What standards should they be held to? How could patient safety be ensured while also allowing legitimate therapeutic innovation? Despite these concerns, the ketamine clinic industry continued to grow rapidly. By 2020, there were hundreds of such clinics across the United States alone. Professional organizations formed to establish best practices. Research continued to try to understand how ketamine worked and how to optimize its use. As ketamine's clinical use expanded, neuroscientists were racing to understand what the drug was actually doing in the brain that produced such rapid antidepressant effects. The initial answer seemed straightforward. Ketamine blocks NMDA receptors, which are a type of glutamate receptor. Glutamate is the brain's primary excitatory neurotransmitter, involved in nearly every aspect of brain function. By blocking NMDA receptors, ketamine was changing the fundamental balance of excitation and inhibition in neural circuits. But that explanation was incomplete. Many drugs block NMDA receptors. Most of them don't have antidepressant effects. There had to be something more specific going on. Research in the 2010s began to reveal a more complex and fascinating picture. Ketamine's blockade of NMDA receptors seemed to trigger a cascade of downstream effects that ultimately led to changes in the structure and function of neurons. One key finding was that ketamine rapidly increased levels of a protein called brain-derived neurotrophic factor, BDNF. This protein is essential for neuroplasticity, the brain's ability to form new connections and reorganize itself. Depression has been associated with decreased neuroplasticity, particularly in brain regions like the prefrontal cortex and hippocampus. Ketamine seemed to be reversing this, creating a window of enhanced plasticity where new, healthier patterns of thinking and emotional regulation could be established. Imaging studies showed that ketamine restored connectivity in brain circuits that were disrupted in depression. The drug seemed to be repairing, at least temporarily, the broken networks that underlay depressive symptoms. Perhaps most intriguingly, some research suggested that ketamine's antidepressant effects might be partially mediated by its metabolites, the compounds that ketamine breaks down into in the body. One metabolite in particular, hydroxynorketamine, showed antidepressant effects in animal studies without producing the dissociative effects of ketamine itself. This raised the tantalizing possibility of developing a new drug based on ketamine's antidepressant mechanism, but without the psychoactive properties. Such a drug could potentially be taken at home, like a traditional antidepressant, without the need for clinic visits and medical supervision. Pharmaceutical companies pursued this vigorously, but as of the early 2020s, no such drug had successfully made it through clinical trials. It remained unclear whether ketamine's antidepressant effects could be fully separated from its consciousness-altering properties, or whether the two were fundamentally linked. Ketamine's success as a psychiatric medication had broader implications. It helped create an opening for serious research into other psychedelic substances that had been banned and stigmatized for decades. If ketamine, a dissociative anesthetic and club drug, could be rehabilitated and proven to have legitimate medical value for severe psychiatric conditions, perhaps the same could be true for other substances. Indeed, the 2010s saw an explosion of new research into psychedelic-assisted therapy. MDMA was moving through Phase 3 clinical trials for PTSD. Psilocybin was showing promise for treatment-resistant depression and end-of-life anxiety. LSD was being studied for anxiety and addiction. Ketamine had blazed the trail, demonstrated the potential, and helped shift the cultural and regulatory environment. It had shown that substances with consciousness-altering properties could be studied rigorously, used therapeutically, and integrated into evidence-based psychiatric practice. The field that emerged was sometimes called psychedelic psychiatry. Though ketamine occupied an ambiguous place in it, it was technically a dissociative, not a classic psychedelic working through a different neurotransmitter system. But it was grouped with psychedelics in practice, part of a broader movement to explore non-traditional treatments for psychiatric conditions. This movement attracted a mix of participants: rigorous academic researchers trying to build an evidence base, therapists and clinicians who had quietly been using these substances for years, advocates and activists who had been fighting for psychedelic legalization, entrepreneurs who saw a business opportunity, and patients desperate for relief that conventional treatments had failed to provide. The landscape was rapidly evolving. Some cities and states began decriminalizing certain psychedelics. Investment capital poured into psychedelic biotech companies. Universities established centers for psychedelic research. It was a genuine renaissance, a rebirth of research that had been killed off 50 years earlier. But it was also fraught with tension. How could these substances be integrated into medical practice without repeating the mistakes of the 1960s? How could access be expanded without creating new epidemics of abuse? How could the spiritual and consciousness-expanding aspects of these drugs be honored while also subjecting them to rigorous scientific scrutiny? Ketamine, with its dual identity as both club drug and psychiatric medication, embodied all of these tensions. It was simultaneously a success story of medical innovation and a cautionary tale about the unintended consequences of psychoactive substances. And its story was far from over. While ketamine was being rehabilitated in Western psychiatry, a very different story was unfolding on the other side of the world. In East and Southeast Asia, ketamine was creating a public health crisis of staggering proportions. The problem was most severe in China, Hong Kong, Taiwan, and Southeast Asian countries like Thailand and Malaysia. Unlike the West, where ketamine was primarily a club drug used occasionally by a relatively small population, in Asia it became a drug of mass consumption, particularly among young people. The scale was shocking. In Hong Kong in the mid-2000s, surveys found that ketamine was the most commonly used illicit drug among teenagers and young adults, surpassing even cannabis. In some schools, as many as 10–15% of students reported having tried it. It wasn't a fringe activity, it was mainstream youth culture. The reasons for this epidemic were complex. Availability. China and India were major manufacturers of pharmaceutical and research chemicals. Clandestine laboratories could produce ketamine cheaply and in massive quantities. The drug flooded the market, becoming readily available and inexpensive. Cultural factors. In many Asian countries, traditional harder drugs like heroin were heavily stigmatized and severely punished. But ketamine was seen as a newer, cleaner drug, associated with modernity and Western club culture. Some young users didn't even think of it as a real drug. It was legal medicine after all, just being used differently. Marketing. Drug dealers in Asia marketed ketamine aggressively, particularly to young people. They created appealing packaging, mixing it with flavorings, selling it at relatively low prices. Some dealers would give free samples to teenagers outside schools, creating new customers. Social patterns. Ketamine use became deeply embedded in certain social contexts, karaoke bars, nightclubs, and particularly the phenomenon of K-parties, where groups of young people would rent a room in a hotel, karaoke bar, or apartment specifically to use ketamine together. The consequences were devastating. Addiction. While ketamine was often described as non-physically addictive, heavy users in Asia demonstrated clear patterns of psychological dependence. They would use ketamine daily, multiple times per day, organizing their entire lives around obtaining and using the drug. Bladder damage. The medical phenomenon known as ketamine bladder, or ketamine-induced ulcerative cystitis, became epidemic. Heavy chronic use of ketamine caused severe inflammation and scarring of the bladder. Patients, often teenagers and young adults, would develop urinary frequency, having to urinate 30, 40, 50 times per day. The pain was excruciating. In severe cases, the bladder would shrink to a fraction of its normal size, holding only a few milliliters of urine, requiring surgical intervention, including bladder removal and replacement with segments of intestine. Cognitive damage. Studies of chronic ketamine users in Asia showed significant cognitive impairments, particularly in memory and executive function. Brain imaging revealed structural changes, including decreased grey matter volume in certain brain regions. Social consequences. Heavy ketamine use was associated with school dropout, unemployment, family conflict, and involvement in crime. The drug created a generation of young people whose development and life prospects were severely compromised. Deaths. While ketamine alone was rarely fatal, it was implicated in numerous deaths, particularly when combined with other substances or when users injured themselves while dissociated. Drownings were particularly common. Users would become disoriented in bathrooms or near water. Hong Kong's response was multifaceted. Public education campaigns, increased enforcement, mandatory drug testing in schools, treatment programs specifically designed for ketamine users. But the problem proved remarkably difficult to control. Ketamine use would decline in response to crackdowns, then rebound. The drug was simply too easy to manufacture, too profitable to sell, too embedded in youth culture. The Asian ketamine epidemic should have been a warning to the West. It demonstrated what could happen when ketamine use moved from occasional party use to habitual, daily consumption. It showed the real costs, medical, social, individual, that the drug could exact. But the warning was largely ignored. Western media coverage of the Asian ketamine crisis was minimal. The two regions inhabited different drug policy universes, rarely learning from each other's experiences, as ketamine was creating public health crises in Asia and finding new medical legitimacy in the West. Its supply chain was evolving in ways that would have been unimaginable just a decade earlier. The dark web, encrypted anonymous networks accessible through specialized browsers like Tor, had created a new kind of drug marketplace. Sites like Silk Road, Alphabay, and their many successors functioned as eBays for drugs, where sellers could offer their products, buyers could compare prices and read reviews, and transactions could be conducted with a level of safety and convenience previously impossible. Ketamine was a popular product on these markets. The drug's legal status as a Schedule III substance in the US, or its equivalent in other countries, made it less risky than heroin or cocaine for both sellers and buyers. If caught, the penalties were generally less severe, and unlike drugs that required precursor chemicals controlled by international treaties, ketamine could be synthesized relatively easily from legal or quasi-legal starting materials. The dark web markets created a global supply chain. Manufacturers in China and India would produce ketamine in quantities ranging from kilograms to tons. These weren't necessarily illegal operations. Some were legitimate pharmaceutical or chemical companies that would produce and sell ketamine for research purposes, with a wink and a nod, knowing full well it was headed for recreational use. Wholesale distributors would purchase these large quantities and divide them into smaller amounts. They would often set up vendor accounts on multiple dark web markets to maximize their reach. Domestic resellers would purchase from these wholesales and further subdivide the product, selling to end users in gram quantities. Individual buyers could purchase ketamine from the comfort of their homes, paying with cryptocurrency, and having it delivered to their mailboxes by national postal services, which were generally less scrutinized than private courier services. The system worked remarkably well for several years. The dark web markets employed escrow systems that held buyers' payments until they confirmed receipt of their product, reducing the risk of scams. They had sophisticated reputation systems where buyers could rate sellers, creating an incentive for quality and reliability. Some vendors even offered customer service, responding to questions and complaints. For ketamine buyers, the dark web offered several advantages over traditional street markets: higher purity, competitive pricing due to the large number of vendors, convenience and relative safety. No need to meet dealers in person in potentially dangerous situations. But the system was not without problems. Quality control was inconsistent. Despite vendor ratings, there was no real regulation. Products might be mislabeled, contaminated, or adulterated. Some vendors sold what they claimed was ketamine, but was actually other dissociatives like methoxetamine or PCP analogues. Law enforcement adapted. Police agencies around the world developed cybercrime units specifically to target dark web markets. Major marketplaces were periodically shut down in coordinated international operations. When Silk Road was shuttered and its creator imprisoned, it sent shockwaves through the community, though successor markets quickly appeared. Exit scams were common. Market administrators, sitting on millions of dollars worth of cryptocurrency held in escrow, would sometimes simply disappear, stealing all the funds. Vendors would sometimes build up good reputations over months, then accept a large volume of orders and vanish without shipping any products. The mail was not perfectly safe. Postal services began using more sophisticated screening, including X-ray machines and trained drug detection dogs. While most packages got through, some were intercepted, leading to controlled deliveries, where police would deliver the package and arrest the recipient. The dark web's impact on ketamine availability was significant. It dramatically expanded access, allowing people in areas without established club scenes or drug markets to obtain the drug. It likely contributed to increasing use in the late 2010s and early 2020s, but it also created a new set of public health challenges. Users buying ketamine online had even less information about what they were taking than users buying from street dealers they knew. The purity could vary wildly from one purchase to the next, making dosing difficult and increasing the risk of accidental overdose. And the easy availability may have contributed to heavier, more frequent use patterns. Then came 2020 and the COVID-19 pandemic, an event that would reshape drug use patterns globally, including for ketamine. As lockdowns closed clubs, raves, and social venues, the context for ketamine use shifted dramatically. The drug that had primarily been consumed in social settings, dance floors, after parties, festival chill-out tents, was now being used alone, in isolation, in people's apartments and houses. This shift had profound effects. Increased use. Multiple studies and surveys documented significant increases in ketamine use during the pandemic. Some of this was likely people self-medicating for pandemic-related depression and anxiety. Some was simply the result of having more time and fewer social constraints. Changed patterns of use. Solitary ketamine use tended to be heavier and more frequent than social use. Without the natural limits imposed by party schedules and social dynamics, some users fell into patterns of daily or near-daily use. Ketamine clinics thrived. As conventional psychiatric services were disrupted by the pandemic, ketamine clinics saw surging demand. Some pivoted to telemedicine models, shipping ketamine nasal spray or lozenges directly to patients for home use, a practice that raised significant safety and regulatory concerns. Supply chain disruptions. The pandemic initially disrupted the global ketamine supply chain. Legitimate pharmaceutical production was affected by lockdowns. International shipping became more difficult and expensive, but the supply chain adapted, and by late 2020, availability had largely returned to normal. New users. The pandemic brought ketamine to the attention of people who might not have encountered it in normal times. Media coverage of ketamine as a depression treatment increased. Celebrities and influencers discussed their experiences with ketamine therapy. The drug's profile was rising. One particularly concerning trend was the emergence of pandemic K-holes, people using ketamine heavily in isolation, sometimes as a form of escapism from pandemic anxiety and the grind of lockdown life. These users were at increased risk for the harms associated with chronic use, and they lacked the informal safety net of friends who might intervene or help if problems developed. The pandemic also accelerated the normalization of ketamine in certain contexts. The line between medical use, ketamine clinics for depression, and recreational use, using ketamine to escape pandemic stress, became increasingly blurred. The same person might be receiving ketamine infusions for depression, while also buying ketamine on the dark web for home use. The contexts were mixing in ways that complicated efforts to understand and regulate the drug's use. As the 2020s progressed, ketamine users began encountering a new and terrifying problem: contamination with synthetic opioids, particularly fentanyl and its analogues. The opioid crisis had created a situation where fentanyl, a synthetic opioid 50 to 100 times more potent than morphine, was being mixed into or substituted for other drugs across the illicit market. The reasons were simple economics. Fentanyl was cheap, potent, and easy to manufacture. A dealer could cut their product with fentanyl to increase perceived potency, or they could press fentanyl into pills and sell them as something else entirely. Initially, this contamination primarily affected heroin and counterfeit prescription pills, but increasingly it spread to other drugs. Cocaine was found cut with fentanyl. MDMA pills contained fentanyl, and eventually ketamine did too. For ketamine users, this was particularly dangerous because the two drugs had opposite effects. Ketamine was a dissociative that didn't suppress breathing. Fentanyl was a respiratory depressant that could kill through suffocation. Users expecting the dissociative effects of ketamine might dose accordingly, not realizing they were actually taking a potentially lethal amount of fentanyl. The problem was most severe in North America, where the fentanyl crisis was worst. Emergency rooms began seeing deaths and overdoses from what appeared to be ketamine, but was actually fentanyl or a mix. Some cases involved deliberate contamination by dealers trying to stretch their ketamine supply or add punch to weak product. Others involved cross-contamination. dealers using the same scales, baggies, or surfaces for multiple drugs, inadvertently transferring fentanyl residue. Harm reduction organizations responded by distributing fentanyl test strips that could detect the presence of synthetic opioids in drugs. They educated users about the risks and encouraged never using alone, so someone could call for help if overdose occurred. But the fundamental problem remained. In an unregulated market, users could never be completely sure what they were taking. The drug that arrived as white powder in an envelope might be pure ketamine, or it might be contaminated, or it might not be ketamine at all. This uncertainty represented a dramatic shift from earlier eras of ketamine use. In the 1990s and 2000s, when most ketamine came from diverted pharmaceutical sources, users could be reasonably confident in purity. That confidence was gone. Every dose now carried an element of Russian roulette. Today, in 2025, ketamine occupies a strange and contradictory position in drug culture. It is simultaneously a psychiatric medication being prescribed in upscale clinics to treat depression and PTSD, promoted by prominent psychiatrists and researchers, the subject of continuing clinical trials and research studies. A party drug consumed in clubs, at festivals, at house parties, particularly in electronic music scenes, often mixed with other substances in unpredictable combinations. A research tool being used to study consciousness, dissociation, psychosis, and the neural basis of subjective experience. A veterinary anesthetic still widely used in animal medicine, still the source of some diverted supply. A subject of moral panic, particularly in Asia, where governments continue to struggle with epidemic levels of use among young people. A tool for spiritual exploration used by some in ceremonial or intentional contexts, often combined with meditation or therapy. The drug defies simple categorization. It is not clearly good or bad, helpful or harmful. It is all of these things depending on context, dose, frequency, intention, and the individual using it. Current use patterns show some interesting trends. Younger users tend to use ketamine in party contexts, often in combination with other drugs. They're less likely to use it heavily or chronically, treating it as an occasional recreational substance rather than a daily habit. Older users, particularly those who came of age in rave culture, may use ketamine more deliberately, in smaller settings or even solo, often with some therapeutic or explorative intent. Medical patients represent a growing category, people who might never have used ketamine recreationally, but who access it through ketamine clinics for depression or other conditions. Some of these patients eventually begin using ketamine outside of medical contexts. Chronic heavy users remain a smaller but concerning population, particularly visible in Asia but present everywhere ketamine is available. These users face the highest risks: bladder damage, cognitive impairment, social and occupational dysfunction. The boundary between these categories is permeable. A party user might develop depression and seek ketamine therapy. A medical patient might enjoy the experience and begin seeking it recreationally. A recreational user might slide into chronic heavy use without intending to. The current regulatory approach to ketamine is clearly not working optimally, but there's no consensus on what would work better. The medical model argues that ketamine should be treated as a prescription medication, with access controlled by physicians and medical oversight. This preserves access for legitimate medical use, while theoretically limiting recreational use and harm. But this model has problems. It creates a two-tier system where the wealthy can access medical ketamine while others cannot. It drives recreational use underground where quality and purity cannot be assured. It limits research by making ketamine harder to study. And it's based on the questionable assumption that physician oversight significantly reduces harm. Many prescription drugs cause substantial harm despite medical gatekeeping. The criminalization model treats ketamine as a dangerous drug of abuse that should be actively suppressed through law enforcement. This is the current approach in most countries where ketamine is a controlled substance. But the evidence suggests this doesn't work. Ketamine remains widely available despite its controlled status. Criminalization has not significantly reduced use. It has created a criminal market with all its associated harms, violence, contamination, unpredictable purity, lack of quality control. It has disproportionately impacted poor and minority communities, and it has hampered medical and research use. The harm reduction model focuses on minimizing the harms of ketamine use, rather than trying to eliminate use entirely. This includes interventions like drug checking services, education about safer use practices, treatment for ketamine-related medical problems without judgment or punishment, and addressing the root causes that lead people to heavy drug use. This model has shown some success in reducing harms, but it's politically difficult in many jurisdictions. It's often mischaracterized as endorsing drug use, rather than pragmatically addressing its reality, and it requires sustained funding for services and education, which is often lacking. The decriminalization-legalization model would remove or reduce criminal penalties for ketamine possession and use, possibly establishing a regulated legal market. This is the approach some jurisdictions have taken with cannabis, and it's been proposed for other psychedelics. For ketamine, this model faces unique challenges. Unlike cannabis or even psychedelics, ketamine has significant potential for harm with chronic heavy use. A legal market would need to balance access against preventing the development of use patterns that lead to bladder damage and other serious medical problems. How would this be accomplished? Age limits, purchase limits, mandatory harm reduction education. No one has convincing answers. The reality is that all drug policy models have limitations and unintended consequences. There may be no perfect regulatory approach to ketamine precisely because the drug itself is so multifaceted, genuinely medically valuable for some uses, relatively harmless for occasional recreational use, but seriously harmful with chronic heavy use. Despite all the uncertainty and controversy, ketamine research continues to advance, potentially revealing new applications and better understanding of mechanisms. Depression treatment optimization. Researchers are working to understand who responds best to ketamine, what dose and frequency is optimal, whether the dissociative experience is necessary for therapeutic effect, and how to maintain benefits long-term without creating dependence. New indications. Clinical trials are exploring ketamine's potential for other conditions: PTSD, OCD, substance use disorders, chronic pain, Alzheimer's disease. Some of these look promising, others less so. Mechanism studies. Neuroscientists are using increasingly sophisticated tools to understand exactly what ketamine does in the brain. Recent research has focused on ketamine's effects on neuroplasticity, on specific neural circuits, on the default mode network, and on the relationship between subjective experience and therapeutic outcome. Novel formulations. Companies are developing new forms of ketamine or ketamine-related drugs, longer-acting formulations, versions that don't produce dissociative effects, combinations with other medications to enhance efficacy or reduce side effects. Psychedelic-assisted therapy models. Researchers are studying whether ketamine's therapeutic effects can be enhanced by combining the drug with specific types of psychotherapy, similar to the models being developed for MDMA and psilocybin. This includes preparation sessions before ketamine administration, guided experiences during, and integration sessions afterward to help patients make sense of and apply insights from the experience. One particularly interesting research direction involves using ketamine as a tool to study consciousness itself. Because ketamine produces such distinct alterations in subjective experience, the sense of dissociation, the out-of-body feelings, the ego dissolution at high doses, neuroscientists can correlate these experiences with specific changes in brain activity and connectivity. This research has implications beyond understanding ketamine. It's contributing to broader questions about the neural basis of consciousness, the nature of self, the relationship between brain and mind. Ketamine is becoming a probe for exploring some of the deepest questions in neuroscience and philosophy. As our story approaches the present day, we're left with profound questions that remain unresolved. Can ketamine's medical benefits be separated from its abuse potential? Is it possible to provide widespread access to ketamine for depression while preventing the development of the chronic heavy use patterns seen in Asia? Or are these goals fundamentally in tension? What are the long-term effects of therapeutic ketamine use? Most studies have followed patients for months or at most a few years. What happens to people who receive ketamine infusions for depression for a decade or more? Do tolerance and dependence inevitably develop? Are there cumulative harms that only become apparent with time? Is the dissociative experience essential to ketamine's therapeutic effects? If pharmaceutical companies succeed in developing ketamine analogues that treat depression without altering consciousness, will they work as well? Or is the subjective experience, the sense of seeing your problems from outside, the feeling of ego dissolution, an integral part of how ketamine helps? How can we prevent the harms of ketamine while preserving access for beneficial uses? This is the fundamental policy challenge. Too much restriction limits medical use and drives recreational use underground with attendant harms. Too little restriction risks repeating the Asian epidemic experience in other regions. What is ketamine teaching us about consciousness and the mind? The drug produces such specific, unusual alterations in subjective experience. What do these tell us about the nature of consciousness, the construction of self, the relationship between brain activity and subjective experience? These questions don't have clear answers yet. The research is ongoing, the social experiment continues, the policies keep evolving. We're still in the middle of the ketamine story. So here we are, at the end of this long journey through ketamine's history. From Calvin Stevens's laboratory in 1962 to the battlefield hospitals of Vietnam, from the London rave scene to the upscale depression clinics of Manhattan, from the bladder wards of Hong Kong hospitals to the neuroscience labs studying consciousness. What have we learned? What does this strange, contradictory drug tell us about ourselves, about our relationship with altered states of consciousness, about the possibilities and perils of pharmacology? Perhaps the most important lesson is this: chemical substances resist simple categorization as purely good or purely bad. Ketamine is a lifesaver on the battlefield and a potential treatment for suicidal depression. It's also a destructive force in the lives of chronic heavy users and a tool for sexual predators. These aren't different drugs. They're the same molecule, in different contexts used with different intentions, producing radically different outcomes. The story of ketamine is a story about context, about how the same substance can be medicine or poison depending on dose, setting, frequency, and purpose. It's about how drugs developed for one use inevitably find other uses, how the medical and recreational spheres are not as separate as we pretend, how human curiosity and the desire for altered consciousness will always find outlets. It's also a story about unintended consequences. The researchers at Park Davis were trying to create a safer anesthetic, not a club drug or a psychiatric medication or a tool for exploring consciousness. But you can't control where a drug goes once it exists, once knowledge of it spreads. Ketamine took on a life of its own, moving through different communities, being reinvented and repurposed, causing harms and providing benefits that no one anticipated. The veterinary supply chain that seemed like an amusing footnote became a major source of diverted ketamine. The dissociative experience that was initially seen as a problematic side effect became, for some users, the point. The medical establishment that initially dismissed ketamine's psychiatric potential is now embracing it. Nothing went as planned, because drugs in the real world never behave the way they do in controlled trials. Perhaps most poignantly, ketamine's story illustrates how our society still struggles to rationally engage with drugs that alter consciousness. We want simple answers. This drug is good, that drug is bad, medical use is legitimate, recreational use is abuse. But ketamine defies these categories. It's too useful to ban completely, too potentially harmful to freely permit, too multifaceted to regulate in any simple way. The War on Drugs framework, which assumes that substances can be divided into acceptable, alcohol, caffeine, prescription medications, and unacceptable, everything else, breaks down completely when faced with something like ketamine. Here's a drug that's FDA-approved, that saves lives in emergency medicine, that shows genuine promise for severe psychiatric conditions, but that also causes serious medical problems with chronic use, that's implicated in sexual assaults, that creates severe addiction in some users. What do you do with that? How do you craft policy that maximizes the benefits and minimizes the harms? Decades into ketamine's existence, we still don't have good answers. Meanwhile, the molecule itself remains unchanged. Ketamine doesn't care about our policy debates or our moral frameworks. It simply does what it does. Blocks NMDA receptors, disrupts neural communication patterns, separates consciousness from sensation, and in doing so creates experiences that some find transcendent and others find terrifying. As we move forward, ketamine will continue to evolve and surprise us. New uses will be discovered, new problems will emerge, new debates will rage. The drug that was supposed to be a safer PCP, that became a battlefield miracle, that transformed into a club drug, that resurrected as a psychiatric medication. This protean substance will keep changing, keep defying our attempts to pin it down and understand it completely. Perhaps that's appropriate, because ketamine, in its fundamental action, separates consciousness from the ordinary constraints of the body and its sensory inputs. It's a drug that takes you outside yourself, that shows you reality from an angle you didn't know existed. It makes sense that it would also escape our usual categories and frameworks, that it would remain always a little beyond our understanding, always slightly beyond our control. The complete history of ketamine is not complete. It's ongoing, unfolding in research labs and dance floors, in depression clinics and hospital emergency rooms, in regulatory hearings and individual consciousnesses. We're all part of this story, whether we've used the drug or not, because how we deal with ketamine, and substances like it, says something fundamental about our values, our relationship with consciousness and experience, our ability to navigate the complex space between prohibition and permission, between medical gatekeeping and individual autonomy. The horse tranquilizer that spiraled out of control, the club drug that became psychiatric medication, the consciousness-expanding tool that causes bladder damage, the battlefield miracle that's also implicated in sexual assault, the potential antidote to suicidal depression that people also use to escape their problems. Ketamine is all of these things, and it will keep being all of these things because that's what drugs do in the real world. They escape the intentions of their creators. They defy simple categorization. They reveal the complexity and contradiction at the heart of human experience. So, as you sit here tonight, wherever you are in the world, whatever time it is, consider this strange chemical compound and the enormous shadow it casts across medicine, neuroscience, drug culture, public health, consciousness studies, and human society. Consider how something synthesized in a Detroit laboratory 63 years ago has touched so many lives in so many ways, for good and ill. The story of ketamine is far from over. New chapters are being written every day, in research papers and emergency rooms, in court cases and medical conferences, in individual minds exploring the far reaches of consciousness, and in policy debates about how to regulate it. The drug that was supposed to be perfect, that was supposed to give us all the benefits of anesthesia without the risks, turned out to be something far more interesting and far more troublesome than anyone imagined. And maybe that's the real lesson. Perfection in pharmacology, as in life, is an illusion. Every drug, every chemical intervention in consciousness comes with trade-offs and complexities that can't be fully anticipated or controlled. The best we can do is try to understand these substances as clearly as possible, to use them as wisely as we can, to minimize their harms and maximize their benefits, and to remain humble about the limits of our knowledge and control. Ketamine has taught us that. It keeps teaching us that every day in 1,000 different ways. The journey continues.